Okay, today we're going to talk about graphing a function from slope-intercept form. Last time we were together, we talked about writing the function based on the graph. So we took a couple of points on the graph, labeled them x1, y1, x2, y2, used them to find the slope, listed our y-intercept, and subbed those components into y equals mx plus b. Today we're going to go the other way around. Today we're going to take the function and we're going to graph it on the coordinate plane. So first off, let's talk about a couple of those things that we had last time. Let's start with slope. What was slope? What did we say slope was? Jordan? The ratio of change in y to change in x. Very good. Now I gave you guys a little trick, a little kind of device to use to remember this, to remember what slope was. It was three little words. What were those three little words? Jesse? Rise over run, exactly. Okay, rise over run. We're talking about how much it goes up or down and how much it goes left or right. Okay, the change in y over the change in x. What was the y-intercept? What did we say the y-intercept was? Hannah? Uh-oh. Beth?
The point 0, 8, x equals 0 to where a function crosses the y-axis.
Very good. It's the point 0b where a function crosses the y-axis. Okay, and you're right. Every single time we have a y-intercept, the x-coordinate is going to be 0. Now, one more thing we talked about last week, or not last week, the other day. What is point-slope form? What does it look like? What does the equation of a line in slope-intercept form look like, Xander?
Y equals bx plus 0.
Really close. Can you give him a hand, Nolan? It might be a fraction, but it might not be.
Y equals a x plus b.
You're really, really close. Quentin? Very good. Y equals mx plus b. Okay? Now, what did m represent? Jesse? The slope. M represented slope. And what's b? What's b represent? Bergie? The y-intercept. Okay? Y and x are variables. Those are going to stay the same. But the m and the x get replaced with numbers. Now, if we have this equation, we can use this equation to graph the linear function. Now, we're going to learn later on how to use an XY chart, and you've actually seen them before. That's another trick that you can use to graph any function, but since we have the equation in slope-intercept form, there's a trick that we can use to graph it a whole lot more quickly. Okay? And that trick goes like this. First off, since we have the equation in slope-intercept form, the first thing we're going to do is identify slope and y-intercept. It's the very first thing that we're going to do. We're going to clearly label it. We're going to write down m equals some number and b equals some number. Now, once we identify the slope and the y-intercept, we're going to plot the y-intercept. And we're going to put that point right on the graph. Now, like you said, at the x-coordinate is 0. It's the point where the function crosses the y-axis. So we're going to put that point on the graph. Then, what was that trick that we said, those three little words about slope? What did we say about those three little words, Gracie? what slope is?
Rise
Rise over run. Okay? So we're going to use the concept of rise over run. We're going to use that slope to count to 2 more points. One on the left, one on the right. Okay, then we're going to take a pause, we'll step back, and we'll look at the graph. And it should be a straight line. If we did everything correctly, the points should be in a straight line. Okay, if they're not, go back and check because something went wrong. But they should be in a straight line, and if they are, we're going to draw the straightest line we can through all 3 points. Now there's a reason that we have to draw that line through all those points, and we'll talk about that when we get there. But we want to make sure that we don't stop at any points. We want to make sure that line goes on and on in each direction as far as it possibly can. Okay? So we're going to look at these equations, and we're going to identify our slope and our y-intercept. We're going to plot the y-intercept. Then we're going to use that slope to count the 2 more points, one on the left, one on the right, and we're going to draw the straightest line we can through all 3 of those points. Okay, so let's start with number 1. Seems like a logical place to start. All right, from number 1, my slope and my y-intercept. Well, my slope is the coefficient or the number that multiplies x. In this case, 3/2. B, the y-intercept, is the constant term, the number that gets added at the end. In this case, 2. So we've identified our slope and our y-intercept. We've clearly written it down. We're not circling, we're not underlining, we're writing down what the variable is and what number it represents it. Okay, then we're going to go ahead and plot that y-intercept. Now the y-intercept is right along this y-axis. It's where the function is going to cross this y-axis at 2. So right here, we put a point at 0, 2. That's the y-intercept. Then we're going to use this idea of slope. We're going to use the rise over run idea to count to 2 more points. Okay, now the slope is 3/2, which means we go up 3, and we go to the right 2. And that's 1 point. Then I'm going to go back to that y-intercept, go back right here, and I'm going to go the opposite direction. So instead of going up and to the right, we're going to go down 3 and to the left 2. Okay, total opposite direction, complete opposite. Okay, now we take a step back and we look, and those points make a nice straight line. So we're going to draw the straightest line that we can through those points. But we're not going to stop at those end points. Now I know that I can sub in any value of x that I want, and I'll get out a y value. You need to show me that you know that. And the way that you show me that is you extend those lines beyond those points. If you stop your line at those points, you're telling me that that function stops at those points, that that function does not exist. A line doesn't exist. The equation doesn't work beyond those points, outside of them. I know that that's not true. I know that the function goes on forever and ever in both directions. You can show me that you know that by drawing a line all the way across that grid. Okay? Plus, next year when you're graphing inequalities instead of equations, you're going to need that line to be all the way across. So develop that habit now so that next year it's a piece of cake. Okay, now let's take a look at the second one. I have y equals negative 2x minus 1. I need to identify my slope and my y-intercept. Now, the slope is the coefficient of x, the number that multiplies x. In this case, that's -2. But when we talk about slope, we like to have it as a fraction. We like to have rise over run. So I want to write -2 as a fraction. How can I take an integer and write it as a fraction? Maddie? Put it over 1. So -2 over 1. Rise over run. Now what about b? What about the y-intercept? Well, it's the constant term on the end. We have to be careful here because there's something tricky. Okay, what should we notice about that constant? What should we notice about that constant term, Bergie? Sorry? It subtracts 1 instead of adding 1. So what does that mean about b? It's -1. Very good. So now we've identified our slope and our y-intercept. Now we're going to go to the next step. We're going to plot that y-intercept. So it's right along this y-axis, okay, and it's at -1. Well, that's right here. Then I'll use that slope idea, that rise over run, to count 2 more points. Now the slope is -2, 1, which means I'll go down 2 and to the right 1. And I'll plot a point right there. Now we also like to have a point on the left side, 1 to the right, 1 to the left. So I'll come back to this y-intercept, and instead of going down 2 and to the right 1, we'll go up 2 and to the left 1. And we'll plot a point there. And now we take a step back and look. Do those points look like they're in a straight line? Looks pretty straight to me. So we'll draw the straightest line that we can through all 3 of those points. And there we go. Okay, and if we can extend that line all the way across that grid, that's the best thing that we can do. All right, what questions do we have about either of those 2 graphs, either of those 2 functions? Yeah. The line never stops. Okay, the cool thing about this function, about both of these, all the ones that we're going to be looking at, I can substitute any value for x that I can think of, and I will get out a y value. Okay, so that means that's a point that I can put on the graph that exists on that line. So yeah, the function goes on forever and ever in both directions. Good question. What else you got? You look like you were about to ask something. No? Got another one? Oh yeah. In fact, the question is, could there be more than 3 points? In fact, the reason this line exists is because there are points between these. There are points again and again between this. And what happens is, those points, there's so many of them, so close together, that they overlap. And it ends up looking like a line. But the truth is, that line exists because there's an infinite number of points just overlapping each other. That's a really good question. You don't always have to have a fraction, but for your slope, since we're using the rise over run idea and we're counting from that y-intercept to another point, we need to know how much we're going up or down and how far we're going left and right. So writing it as a fraction makes that a little bit more obvious to us. Okay? Mm-hmm. So just a vertical line and no left and right? that equation actually would look very, very different from these. Okay? And we will talk about that at some point, but not right now. Okay? Good question, Bass. All right, let's look at the next couple. Okay, next up, I have y equals x minus 3. I still want to do the same thing we always do. I want to identify my slope and my y-intercept. Okay? So the slope, that's the coefficient of x. That's the number that's multiplying x. So, Crystal, what's multiplying x here? 1. Okay, there's nothing multiplying x, so there's an invisible 1 there. Now again, Crystal, we don't like to have just the integer. For our slope, we like to have a fraction. So how can I turn 1 into a fraction? Very good. Put it over 1. 1 over 1. Great. Now how about the y-intercept? It's negative 3. Okay, they're saying x minus 3. The formula is y equals mx plus b. So we take the opposite sign, and we have b equals negative 3. Now, I need to start by plotting that y-intercept. Okay, Miss Hannah, where's the y-intercept going to be? Sorry? That's the slope. Down 3. Okay, I go from the origin down 3. The y-intercept is right on that y-axis, and because it's negative 3, it's going down 3. Now, I want to count to some points. Well, Brielle, how will I count to a point here? From this y-intercept, how can I use the slope to count to another point on the line? 1 up and 1 to the right. Okay, good. Now, Brielle, I'm going to come back to that y-intercept, and I'd like a point on the left side. Can you help me get one on the left side? Good. Down 1 and 1 to the left. And I want to point out something that she did there really, really nicely that not a lot of students do. She said up 1 and to the right 1. Down 1 and to the left 1. What a lot of students will say is up 1 over 1. Well, there's a little problem with that because over can be to the right, but it can also be to the left. Okay, up and down, they're specific. Okay, it's obvious if you're going up or if you're going downward. But over isn't clear. So when we're counting, we need to be very, very clear. Up 1 to the right 1, down 1 to the left 1. Okay? Now, we've got those lines, or excuse me, we've got those points. Take a step back and look. They're in a pretty straight line. So we'll use the straightest line we can to connect those points. Go through all 3 of them. And there we go. Mm-hmm. Okay, again, the slope in this case is an integer. Okay, it's just 1. But for our purposes, because we're using that rise over run idea to count from our y-intercept to another point, we need to have both a rise and a run. Okay, so we need to know what those are. So by writing it as a fraction, now I know what the rise is, I know how far to go up or down, and I know what the run is. I know how far to go left or right. Okay, that's why we write it as a fraction, so we can clearly see that. Okay? All right, Barsha, how about number 4 here? I have y equals negative x plus 1. What about negative 1? M equals negative 1, and b equals positive 1. Now, Bass, what should we do, though, with that slope? Right now, the slope's an integer. I want to write it as a fraction. Okay, why? Very good. That helps us see rise over run. Okay, good. So how would I turn this into a fraction? -1/1. Great. Okay, Chase, what's the first thing I'm going to put on this graph? Hold on.
Please pardon this interruption. At this time.
Sorry about that interruption. Okay, try again, Chase. Okay, the y-intercept is +1, so we start at the origin, and we go up 1. Great. Okay, now, this, Jordan, can you help me count to another point? Very good. Down 1 and to the right 1. Okay, so I've got 1 point over here on the right. Now, Jordan, I'd like to get another one on the left. So if I go back to this, back to the y-intercept, very good. Up 1 and to the left 1. Okay, total opposite. Okay, take a step back and look. What am I looking for when I take a step back and look? After I plot those 3 points, this, Jordan, they should be in a nice straight line, are they? Looks pretty good to me. So, Katia, what now? Good. Draw the straightest line we can through all those points, as far across the grid as we can. All right, and there we go. Yes? No. Okay, it does not matter which side you go to first. You just want a straight line all the way across. Okay? Just as long, are you talking about when you're counting the slope? Or? It's easier to go to the right because when you go to the right, you're using the numbers that you actually have. Down 1 to the right 1. Okay? Up 1 to the right 1. Okay? Once you have that, then you know, okay, when I go to the left, I'm going to go the complete opposite. Okay? Yeah. The x values on the left are negative. The x values on the right are positive. Okay? Y values can change. Y values can be positive or negative on left and right. Okay? What other questions do you have? All right, then I'm going to give you guys about 5 minutes, and what I'd like you to do is graph the remaining 2 functions. Y equals -2/5 x plus 2, and y equals -2. All right, so let's see. Hannah, Hannah, can I get you to put your work up for number 5, please? Mm-hmm. Okay, keep writing. I'm just going to talk, okay? So she has m is -2/5 and b is +2. She plots a point on the y-axis at y equals +2, okay, because that's what the y-intercept is. Now, she's counting. You know, she's erasing back to the pen, and she counts down 2, and she counts to the left 5, plots a point. And then she's counting up 2, and to the right 5. Okay, well, Hannah, you're halfway right. Okay? What you want to do, you had the right idea. Okay? The first number's up and down, the second number's left and right. Okay, the problem is you had them backwards. Okay, when you count -2/5, okay, down 2 and to the right 5. Okay? Always left to right when we're talking about graphs. Always, always, always left to right. Okay? Now to go backwards. Now we know we're going backwards. Now we're going right to left. Okay? We're going to do the total opposite. So up 2 and to the left 5. Okay? All right. Now draw the straightest line we can through those points all the way across the graph. Okay? And Courtney, can you come on up and put your work for number 6, please? Thank you. Okay, so her slope is 0 over 1. Her y-intercept is -2. So she plots a point on the y-axis at -2. And for her next points, notice she doesn't go up or down at all. She just goes left and right because the rise is 0. So she's not going up, she's not going down, and she runs 1 in each direction. Then we just draw a straight line all the way across the graph. Very good, Courtney. So, when we're graphing these functions, guys, hold up a second, please don't pack up yet. When we're graphing these functions, first, we identify the slope and the y-intercept. Plot the y-intercept, use the slope to count to 2 more points. Remember, rise over run. Okay? All right.